have stressed for a very long time, and I need you guys to focus. If a arc is 2 letters, that means it's a minor arc, correct? That means it has to be less than half the circle. Agreed? So wouldn't arc AB be this one? So if arc AB is that one, then what does that mean AB is? Savannah? 158. Okay? So you should have gotten that this arc was 202 degrees. Savannah did get that. She multiplied the 101 by 2. So you do 101 times 2 to give you that arc. Then she did 360 minus the 202. Am I right, Savannah?
Yeah.
And that's how she got the 158 degrees. Okay? We Gucci on that one? If it's 2 letters, what kind of arc is it? Minor. Okay? So, FH. Dylan?
But no, it's still not number 1.
Oh, okay.
How would you write the bigger arc?
You couldn't label it the way that it's written,
Oh, okay.
right? It would have to have a point here that would say like D or something. Okay? All right. Number 2, the measure of FH. Xavier?
102.
How'd you get that?
Because angle, like the other angle on the other side has to be 51.
Why?
It's supplementary to 129.
Good. So 180 minus 129 gives you 51. Okay.
And I doubled that.
And then you doubled it and you got 102. I agree. Christian? It's 11:11, guys. All right. Number 3, the measure of angle 1. Jaden?
248 divided by 2.
Good. 248 divided by 2. What'd you get? You can use your phone.
I got 124.
124.
And then you know it's supplementary. So we'll go 180 minus 124.
What'd you get? It should be like 56, right? 56 degrees? Very good. Okay. Are we okay with these? Now remember, line T is what compared to the circle? What kind of line is line T? In all of these examples. It's tangent, okay? Please highlight that on your page, okay? That's super important. Line T has to be tangent in order for this to apply, where the circle portion is double the angle, okay? All right, and before we... All right, chapter 10, section 6, segment relationships in circles. Please, please, please highlight, underline, whatever you need to do. Segment relationships, okay? We're not going to be talking about angles in this section. We're going to be talking about segments, okay? So it's literally the length of the segment, okay? And the first one is super, super easy, okay? It says when 2 chords intersect in the interior of a circle, each chord is divided into 2 segments called segments of the chord. And they have a really, really cool relationship, okay? And the relationship that they have is that if you pick either of the chords, okay? For example, let's start with the chord DC, right? Do you see how when they intersect each other, DC as a chord is broken up into 2 parts? What are the 2 parts? Xavier? DE and EC, right? We multiply those, and it'll be the same as the 2 parts of the other chord multiplied together, okay? So we multiply DE and EC, and that will be the same as AE times EB. Okay? So when 2 chords intersect each other on the inside of a circle, they're going to be broken up into 2 parts, each of the chords respectively. If you multiply those 2 parts together, they're the same, okay? So in other words, the two parts of DC are DE and EC. We multiply those two together. That will be the same as AE times EB.
Yeah. So
Okay, and that's just represented down below. So you guys go on to the next slide, fill in the parts that you're missing. Yeah, Savannah?
After this, can you go back up just like a minute?
Yep.
Sorry. I have a really weird ear pain.
Okay, so guys, when we're talking about this problem, okay, or a problem like this, let's talk about how we could go about proving this. What in this photo can we put congruence symbols on? What do we know is the same in this picture?
The two vertical angles.
Very good. There's two vertical angles. So we know that this angle, AED, and CEB are congruent, okay? Now, I'm going to go ahead and draw two additional lines to create two triangles. What do you guys think we could use? So, what do you think is true about those two triangles that I have now? Talia?
AED and let's BEC.
What about them? Yeah, those are the two triangles. Are they congruent?
Yeah.
They're the same size?
No.
No.
But the
They're
lines are-
similar, okay? Now, let's try to figure out, in order to prove that something's similar, we need more information. Christian?
CE is perpendicular, similar to DE, and AE is similar to BE.
You are correct, okay? But we're trying to prove that. You're 100% correct.
Oh.
So the reason that this works is because these triangles are similar. But we need to prove that they're similar first. Xavier, what do you see?
EAD and CVE are congruent, like the angles, because they're also X.
Okay, yes, but we don't know that these two lines are parallel. You're on the right track though, okay? Is there another way that we can prove, and let me draw it out for you, what Xavier is saying. He's saying that this angle is congruent with this angle in blue. Why else would those two be congruent? Let me show you on the board. This one, why would that be congruent to this one?
And the same arc.
They have the same arc. So if they have the same arc, don't they have to be congruent? Would that also apply to those two angles on the bottom? And if all of the angles in your triangles are congruent, aren't they similar? So if we have two similar triangles, aren't all their sides proportional? So if AE is proportional to, for example, CE, right? And we set that equal to the other side, which is DE over CE. Do you agree? When we cross multiply, what do we, or did I set that up wrong? Shoot, I did. What do I need to change? I used CE twice, right? It should be BE on the bottom. So now when I cross multiply, I'm going to get AE times BE, which is equal to CE times DE. Okay, now you guys just need to have this theorem memorized, but I do like to show you where these things are coming from. And it stems from the fact that these are two similar triangles, okay, based on all their angles being congruent. So we can set up a proportion and we can cross multiply, and that's where our formula comes from. Yes, Savannah.
If there was alternate angle, or like alternate interior or whatever, wouldn't C and D be congruent, not A and C?
Can you also change the font color?
I think, yeah. You are correct. Since we don't know that these are parallel, right? You're correct. They wouldn't be alternate interior. Yeah.
So C and D are congruent, not C and A.
So, no. You're right. They're not alternate interior.
Oh, they're not all.
They're not alternate interior. No. Okay? Because we don't know that these two are parallel, right?
Oh, we just know they're congruent.
We just know that the angles are congruent. So like C, right, as an angle is congruent to angle A,
Okay.
not to angle D. And D is congruent to angle B.
Oh, okay.
That's why when we were making the proportionality statements, BE was similar to DE,
Okay.
right? The two bottom sides were proportional. And AE was proportional to CE. Okay? All right. Let's use this theorem in a very easy example, okay? So we've got two chords, they intersect, right? So we end up getting 4 parts. Which 2 parts should I multiply by each other? 6 and 4. And that should be equal to what? 3 times x. 6 times 4 is? 24. And 3 times x is? 3x. How do I solve? So x equals 8. Okay, so I'm going to go ahead and highlight the portions. Remember, the 4 and the 6, do you see they were part of the same chord? That's why they get multiplied together. And then the x and the 3 are part of the same chord. That's why those two get multiplied together. Yes? What do you think we do for number 2? Go ahead, Christina.
2 times x plus 1
Good. 2 times x plus 1
equals 4 times 3.
equals 4 times 3. Excellent, okay? The two pieces of each chord multiplied by each other, okay? So, what do we have to do, though, to multiply 2 and x plus 1? Distribute, okay? We're not foiling because it's not two binomials, okay? But we do have to distribute. So 2 times x and 2 times 1. So we get 2x plus 2 equals 12. Then what do I do? Subtract 2. I'm going to get 2x equals 10. And then x equals 5. Because we divided both sides by 2. Cool beans? So are the chords the same length? Are the chords the same length? No, they're just proportional, okay? The chords are not the same length, but their sections become proportional. Because if we plugged in 5, do you agree that this side would be 6 in total? 6 plus 2 is 8, right? So that one's 8. What's the other one's length? 7, right? Are 8 and 7 the same? No, so your chords are not the same length. Only when you multiply their sections together, right, are they equal to each other. The first one would not be the same length because x was 8, right? So together those two make 11, and the other one only makes 10. Okay? No. Mm-mm. It just happened to work that way for these two. Okay, so the other segments that you guys need to know are called secant segments. A secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of a secant segment that is outside the circle is called an external segment, okay? So a secant intersects the circle at 2 points, right? It kind of just passes through the circle. It's not tangent, right? A tangent would only intersect it at 1 point. So if it's secant, it's going to intersect at 2 parts. We call the external segment, which is the red segment, external. And then the black segment is technically the internal one, right? And the whole thing would be called the secant segment, okay? You have to be specific, though, because secant on its own refers to a line. So it has arrowheads, right? You have to say that it's a secant segment because it's not a line, okay? It's actually a segment, okay? It has a value. So the theorem that stems from this, let me talk about a tangent segment. So we talked about a tangent before. A tangent segment is just a segment that is tangent to a circle at an endpoint. If two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment, okay? In other words, the whole times the external is the same as the whole times the external. I'm going to use colors to try to stress this, okay? The whole would be LN. And the external means it lies outside the circle. That would be from M to N. Do you guys see that? So that whole times the external, MN, is going to be equal to the other segment, which would be PN, the whole, and then times the external, which would be ON, the external. So it's very similar to when two chords intersect inside a circle, right? We have proportionality. But here it's a whole segment times an external segment and a whole segment times an external segment. And where this comes from, guys, is because you can draw two lines here and here that also create proportionality. Okay, so these two triangles are similar as well. If one of your segments is not a secant, it's a tangent. Instead of multiplying it by the whole times the external, you just take the length of that tangent and you square it, okay? So you multiply it by itself. So, guys, stop writing just for a second. Do you guys see how LM is no longer a secant? It's a tangent because it intersects only at one point. This is where we would square it, okay? So that's the important part. You can keep writing, okay? So the other one's a secant, so we follow the same pattern. We do the whole secant times the external portion, which is LK, and we set that equal to the tangent squared. Now, these two lines must share an endpoint, in which case, in our example, is L. They must share an endpoint outside the circle, okay? In order for this to happen. The inside of a circle, two chords intersecting inside a circle, what would you guys do here? 12 times 2 and 3 times x. And set it equal to 3 times x. You're going to get 24 equals 3x. Divide by 3 and you get x equals 8. Now, B is where things look a little different, okay? Is this an example of two secant segments, a secant and a tangent, or two tangents? Secant and a tangent, okay? So we're going to take the whole of the secant. What would the whole of the secant be, guys? It would be 18 plus 6. Do you guys see that? 18 plus 6. So the whole of the secant is 18. Oh my gosh, why can't I write? 18 plus 6. And we're going to multiply that by what? The external portion, which is just 6. Then we set that equal to x, which is our tangent portion. And what do we multiply x by? Itself. So we square it, okay? We multiply it by itself squared. Because do you guys agree, right? Isn't the external portion just the whole as well? Because there's no internal portion? So wouldn't you just be multiplying x by x? That's one way to think about it. You can either think about it as tangents need to get squared, or it's whole as well times external, which they're both the same, so it'd be just x times x. All right, what's 18 plus 6? I think it's like 24, right? 24 times 6 equals x squared. 24 times 6,
It's
144. And if you take the square root of that, it's 12. So x equals 12.
Are we using calculators?
Yep, you're still going to have calculators in this chapter. All right, any questions on B? Okay, let's do another one. Does 3 have any tangents? No. It's 2 secant segments, okay? So we're going to take the whole of this one. What's the whole of that one? 9 plus 6, which is 15, and multiply it by what? 6, the external portion. Yes? And then we set that equal to the whole of this bottom one, which is what? 5 times x, or excuse me, 5 plus x, and multiply it by 5, okay? The external portion. So we're going to get 15 times 6, which will give us 90, equals, distribute the 5 to both terms, 25 plus 5x. We would subtract 25 from both sides. 65 equals 5x. And we get x equals 13. Questions on this one, Christina?
confused how you can tell the difference between a secant segment.
So a secant segment is going to intersect our circle at 2 points. A tangent will only intersect at 1 point. Do you see how this one, right, was tangent? It doesn't have an internal portion. It doesn't go inside the circle. It only stays on the external, okay?
So one side, it stays outside of the circle and it's a tangent.
Correct. Now, number 4, right? These, even though it's very close, do you see how there is still an internal portion here?
Yes, it's the same.
It's still a secant segment, okay? What would you guys do to set up number 4? 3. Yeah, go ahead, Gabby.
3 plus x plus 2 multiplying 3,
Good. How'd you get that?
because you have to multiply by the outside part.
Good. So it's whole, which is 3 plus x plus 2, and then times the external. Okay. Try the other one.
And then do x plus 1 plus x minus 1 times
X plus 1 plus x minus 1, and then times
x plus 1.
plus 1.
And then 4.
Mm-hmm. So let's go ahead and simplify. The 5 and the 2 will the 3 and the 2 will combine to give me 5. So it'll be x plus 5 over here times 3 equals, and then we're going to get 2x minus 1. Nope, excuse me, just 2x. Because positive 1 and minus 1 are going to cancel, and then times x plus 1. So in this one, we're going to get 3 times x, 3 times 5, 3x plus 15 equals 2x times x will give me 2x squared, and then plus 2x. This one, I need you to know how to set it up, okay? But I will not ask you to solve a quadratic here, okay? So if there's ever an x squared, you'll either take the square root or that x squared will disappear because there will be the same x squared on both sides, okay? You'll never have, so like, do you guys see how the x squared will not be able to go away? Like, we're gonna keep that 2x squared. We could subtract 3x from this side, and we could subtract 15. And we would get 0 equals 2x squared minus x minus 15. Guys, I'm not going to ask you to solve something like this, okay? But this example is good for knowing the setup, okay? How we dealt with the x terms and setting it up, okay? If I ever ask you to solve one of these, the x squared will be the same on both sides, so when you subtract it over, it'll go away, okay? I will not ask you to solve a quadratic. Please make a note of that. Ooh. Few more.
I don't think we have it in the homework for today.
We don't.
No.
I'll double check.
I didn't see something.
What do we do here? How do we set it up? Savannah, go for it.
You're gonna do 8 times 4, plus 4, equals, x times 6 plus 6. And then you solve it.
Not quite.
No?
No, wait.
So,
See what I got?
yes. You have to add before you multiply. Okay? So,
Oh, sorry, I think I said that wrong. I meant 8.
8 plus 4
Yeah, that's-
times 4. There you go. So it should be 8 plus 4 and then multiplied by 4.
Yeah, that's
And x plus 6 and then times 6. Okay? Xavier, what do you get?
I got 48 equals 6x equals 36.
Good. So you're going to get 48 equals 6x plus 36. What'd you do after that?
I subtracted 36, so it's 12 equals 6x.
Mm-hmm.
And then divide by 6, x equals 2.
Good. X is equal to 2. Perfect. Okay. Why is D a little bit different? Jaden?
Because it doesn't have the end. Wait, no, one's a tangent.
One's a tangent. Very good. What do we do with tangents in our formula? Mariana? You square it, okay? So we're just going to take that 10 and we're going to square it and set it equal to what? Mariana?
2x plus x.
Good. I believe this one will also give us a quadratic. Let's just double check. So we're going to get 2x plus x, so this will be 10 squared, which is 100, equals, this will be 3x times x. So this will give me 100 equals 3x squared. You would divide by 3 to both sides. So you would get 100 divided by 3, which give me 33.3 equals x squared. And we would take the square root of both sides. And we would get 5.8 equals x. Now, I would expect you to solve something like this, okay? The reason I would expect you to solve something like this is because, do you see how when it boiled down to it, there was just an x squared term? There wasn't like x squared plus an x term and then plus a constant, okay? This, we all know how to take the square root. So this would be okay to see. But I would not ask you to solve a quadratic with that middle term in there as well, okay? Jaden, what's up? Yes. Okay, and the last one. How do you think we set this one up? Mariana?
Is it R plus 8 times 8?
Good. R plus 8 times 8. Because the whole thing would be R plus 8, and the external portion would be 8. And then we set that equal to 20 squared. Very good. R plus R is going to give me 2R plus 8. Multiplying that by 8 equals, and then 20 squared is 400. 8 times 2R will give me 16R. 8 times 8 will give me 64, and this will set equal to 400. We'll subtract the 64 from both sides, get 16R equals 400 minus 64. Gives me 336. Divide everything by 16. We get 21, so R equals 21.